Number 3 then, A3 from the 2012 Advanced Higher Applied Maths Mechanics paper. Distance, speed, distance, time. A little graph here, a little velocity time graph. Looks in order here. What have we got? A sprinter competes in a 100-metre race. Well, there you go, area under the graph 100 metres. Starts from rest and for the first 4 seconds has got this speed. And there's an acceleration, but it's not a constant acceleration. It follows this formula. 13 upon 2t minus t squared metres per second. So there we go, that's a parabolic path for the graph there. And that's for t up to 4 seconds. The next 6 seconds, so up to 6 seconds, constant speed of 10 metres per second. So that must mesh with that. So presumably putting 4 into that must give you a 10, which you can try yourself. And then after that, greater than 10 seconds, there's a constant deceleration of 0.4, 2/5 of a metre per second squared. How about a wee picture of this then? So what's happening? So for the first, so velocity up the way, speed along the way, time along the way, sorry. So for the first 4 seconds, it's some parabolic path. Then there's a constant 10, taking you up to 10 seconds. And then there's a deceleration, a constant deceleration, so that'll be a straight line sloping down, but not necessarily going down to 0. So you finish at the line exactly at a standstill. That'll be a deceleration through the line. So unfortunately for this little bit here, this end part is going to be a trapezium. So I've got a parabolic section, a rectangular section, and a trapezoidal section. Well, let's work out these 3 distances. There's S1, there's S2, and then there's S3. It's a pity it's not a triangle. Still, S1. Now the first one would be the area under the curve. So if that's the velocity, it'll be the integral from 0 to 4 of that expression. 13 upon 2t, t minus t squared dt. Or you could have started by saying, well, if v equals 13 upon 2t minus, it's a bit of a tongue twister that, upon 2t minus t squared, then that means ds upon dt is that. I'm getting fed up writing this already. And then we can have to do ds, no, just put s equals the integral of blah blah, same as this. I'm just going to stay in with this. So what have I got? There's no point taking out halves and things here. It's not going to help, is it? So that's 13t squared upon 4 minus t cubed upon 3 to be evaluated from 0 to 4. Well, at least at 0 it's going to disappear. So it's 13 times 4 squared upon 4. Well, it's just 4 13s. Minus 4 cubed upon 3. Minus 0. But you can just press the buttons for that. And you get 92 upon 3 metres. Which is, of course, a 30 2/3 metres. So there's your first 2 marks. First one for integrating to get the distance covered in that time, and the second one for evaluating it. Now what about the next one? What about the distance travelled in the second one? Well, that'll just be distances, speed times time. Do I have to put the formula in? Well, I haven't now. 10 times, and that was 6, so that was 60 metres. But that's not a mark. The mark comes from getting the total distance so far. So in the first 10 seconds, it'll be the 2 of them added together. So far I've got S1 plus S2 is 30 2/3 plus 60, which is 90 2/3 metres. That was the third mark. So it's a 6-mark question, which really means the remaining 3 marks are for working out this little trapezium part of the graph at the end there. How long would that take? What is that little time interval there after the 10? Well, certainly you can work out what the distance is going to be. It'll be 100 minus 90 2/3, which is 9 1/3, or I'll just pop that in as 20 upon 3 metres. Let's just get this up the top for this last little section. Now, if it was a nice little triangle, that'd be so easy. If you know the area of the triangle, which would have been that distance, and you knew the height of the triangle, which would have been the 10, then you could have found the time quite easily, but it's not, it's a trapezium. You could still find the area of the trapezium, as in the average of the two parallel sides. That side's 10. That side will be using the equation v equals u plus at, but I'm not sure if I'm going to follow this path. V equals u plus at would give you the velocity for that part in terms of t. Then the average base times the height, which is t, would give you an expression in terms of t to equate to 9 1/3, but I think that's just going to be a bit messier than just going straight in with one of your stuvas for the distance. S equals ut plus a half at squared, because I know all the bits and pieces of that. I know that S is 9 1/3, or I'll go in for this one here. I've got 20 upon 3. U, the initial velocity, was 10. T, I don't know. A half of, A was negative 2/5. And T, I don't know. And there's a quadratic. Just rearrange that into a well-known phrase or saying. And I've got what? Well, that's a fifth. And that's a third. So I'm going to multiply everything by 15 here and take it over to one side. Well, that'll be the easy term there, won't it? Because that'll be 150t. And this one here will stay positive. It'll just be 5 times that, which will be 140. And it's just this little bit here. That part's to get multiplied. It's just going to be a 3, isn't it? 3t squared. So I've got to solve that. And you can bet your bottom dollar that's not going to factorise nicely, so I'm going to have to use the formula. Right, so negative of b, 150, plus or minus the square root of 150 squared, minus 4 times 3, I'll just jump straight in with a 12, times 140, a calculator's going to do it all anyway, over 2a, which is 6. So putting in with the minus first of all, which of course might not necessarily be a negative answer, gives me either t is 0.951 seconds, or replaying it with the plus gives me, t is 49 point. We're not going to win any races with that, so that doesn't seem reasonable. So that must be the area of that trapezium, the one that you want, not the area, the time for the area to equal that. For the area to equal that positive again, that would be the same as carrying this down into a triangle, which of course has got a bigger area, and then going underneath again, continuing on until the negative triangle underneath cancels out sufficient of the positive one to leave you 9 1/3. But that's not what you want. This will be the answer here then. So that would be the time. So the time will be 0.95 seconds, which makes the total time for the race then would be 10 plus that. You can just jump straight in, or do you have to write it? 4 plus 6 plus 0.95, which is 10.95 seconds. It seems to be that getting 9 1/3 was 1 mark, ending up with that equation was 1 mark, and then getting the final answer. One other thing you might notice about this, remember that equation to begin with was what again? It was 13 upon 2t minus t squared. As a parabola, if I was to factorise that, t times 13 upon 2 minus t, that would have t equals 0 or t equals 13 upon 2 as the start and finish off, if you like, which means the midpoint, the highest point in that would have been at the time, which is 13 upon 4, which is just 3 1/4 seconds. So following that acceleration, you'd accelerate to maximum speed after 3 1/4 seconds, which means that at 4 seconds you were actually slowing down again. So that path didn't actually look like that. Not that it mattered for the question, just in terms of the actual running mechanics of it. That must have gone up and then been slowing down and then passed on. Still, the answer is still 10 when t is 4. But you thought they would have accelerated to a maximum speed and then continued it. Still, didn't actually matter for the question. There it is, 6 marks.